Hi, welcome to Singapore Management University. I'm Archon Misra, Vice Provost of Research at SMU and a Professor of Information Systems. Let me start by sharing with you a very brief introduction about our university. We're a premier research-intensive university in Asia. We're now 20 years old, and our city campus is a state-of-the-art facility located right in the heart of downtown Singapore. Now, while often initially views SMU as a management university, I should correct this misperception. We actually have 6 schools spanning social sciences, management, and computing technology. Our computing school conducts both foundational and translational research in various areas of technology, such as cybersecurity, machine learning, low-power and embedded computing, and human-computer interaction. In our strategic plan, the SMU 2025 vision announced earlier this year, the university has selected 3 priorities to serve as cross-disciplinary focal points across all our 6 schools. Now, these priorities are digital transformation, sustainable living, and growth in Asia. Now, they were selected both because they address the future needs of Singapore, the regional economy, and our community, and also because they align very well with SMU's unique cross-disciplinary strengths and our faculty expertise. You'll actually hear from some of our faculty about their respective research interests in AI, which is one of the themes under the strategic priority of digital transformation. So some of the AI-related technology work will include topics such as meta-learning, where my colleague Sun-Chian Ru will look at automatically inferring the right hyperparameters and model structures for new unseen ML problems. It'll have topics such as natural language processing and vision, which in turn support capabilities such as multimodal instruction comprehension. Now, this refers to the ability to use vision, voice, and gestures to support natural human-robot interaction. It'll also include significant work by our faculty on decision optimization. This is an area that combines reinforcement learning and game theory to tackle problems of urban resource optimization, such as dynamically repositioning emergency response vehicles to cut down emergency response times. My colleague Akshat Kumar, who's been recognized as one of AI's 10 to watch by the IEEE Intelligence Systems magazine, will share a little bit of work on this topic. We have new emerging work on quantum-based optimization algorithms. Now, these are algorithms that can find global maxima or minima for large-scale problems that traditional approaches just cannot tackle. We have faculty also developing AI-based mechanisms to perform automated debugging and repair of very complex software. Now, my colleague David Lowe will talk more about this area of research later on. Our emphasis on interdisciplinarity is also reflected in our pedagogy. So while our AI track in our computer science major emphasizes core machine learning and multi-agent optimization techniques, our pioneering computing and law major, a distinct major, looks at harnessing the power of computing and AI, but together with relevant legal frameworks and ethics issues that lie at the heart of the new digital economy. I hope many of you will find our emphasis on intellectual excellence and impactful research of interest. And I really welcome you to reach out to us to explore your interest in these topics in greater depth.
Hi, my name is Akshat Kumar, and I'm an Associate Professor of Information Systems in SMU. My research interests lie at the intersection of AI and machine learning with a focus on multi-agent decision-making and reinforcement learning. I'm particularly excited by the application of large-scale multi-agent planning and learning for optimizing urban systems, including land and maritime transportation. As our society and urban environments are rapidly becoming connected, they present an opportunity to deploy autonomous agents such as self-driving cars, taxis, and autonomous vessels, which promise to radically improve productivity and safety, while reducing human efforts and risk. For example, autonomous ships already on the horizon are predicted to significantly alter the maritime traffic. In busy ports of the world, a key problem is how to ensure a coordinated movement of ships that ensures just-in-time arrival and at the same time maintain safety of navigation to avoid environmental disasters such as oil spillage. Using coordinated decision-making can help achieve these objectives of safer and efficient navigation. My research aims to develop decision-making models and algorithms that enable multiple agents to coordinate with each other. One key problem I am addressing is that of scalable solution methods. Connected urban environments would require coordinating very large number of agents. Furthermore, we may soon find our lives with more AI-based technologies such as human-driven cars and autonomous taxis sharing the road. Another key question I'm exploring now is how to design safe algorithms that enable productive cohabitation among humans and AI agents as much as possible. I believe that addressing these challenges is going to be not only academically exciting, but will also create significant societal impact in an urban city such as Singapore.
Hi, I'm David Loh, and I'm a professor of information systems at SMU and the director of the Research Lab for Intelligent Software Engineering. I've been working in the area of software engineering for the past 15 years, and my interest is in the intersection of software engineering and AI. One direction is in the application of software engineering research to AI, known as trustworthy AI. And together with my other colleagues, we are interested to answer research questions such as how to ensure correctness, robustness, fairness, and security of AI systems, how to certify AI systems, and how to engineer and maintain evolving AI systems. In this direction, we have a research project funded by the SMU Internal Research Grant on testing and verification of artificial intelligence systems, which aims to develop testing and runtime verification solutions to ensure that AI systems are reliable and can abide by safety and ethical properties. Another direction that we are looking at is in the application of AI to software engineering, known as AI Ops. We are interested to develop solutions for effective human-AI collaborations to boost productivity in various aspects of software development, as well as the reliability and security of systems. In this direction, we have a research project funded by the Singapore Data Science Consortium called Making Big Code Active from Billions of Code Tokens to Automation. The project seeks to unlock the power of large software data stored in open software repositories for automating 3 common software development tasks: code completion, code summarization, and defect prediction. It is my belief that advancements in these 2 research directions will benefit everyone in the world today where software is ubiquitous.
Hi, I'm Sun Qianru, an assistant professor of information systems at SMU. My research interest is in computer vision and machine learning. More specifically, I'm looking at how we can empower AI with causal reasoning so that it can truly understand the real world. AI is good at watching tons of data, which are the collections of our human lives, and it beats us in data-driven tasks such as memorization and imitation. Unfortunately, AI still fails in trivial humanity, such as common sense and sympathy. To make AI truly understand the real world, we need to empower it to pursue causal reasoning. We want to help the researchers to get rid of the trap of making bigger and bigger data sets. It is our hope that we will enable the AI models to do robust predictions based on only weakly supervised or few-shot data. 2 examples of our methodologies are given. 1. Causal interventional training. This makes AI aware of the fact that the representation of the data are not good enough. Our training can benefit AI in using not only the conventional supervised, but also the weakly supervised data, which can cover the reasoning in more comprehensive tasks. The second example is on counterfactual inference for rare or unseen data. Causality can help the AI to imagine a counterfactual situation that doesn't exist in observations. By answering the counterfactual question, what if, we can easily resolve the crux of many very elusive tasks, such as few-shot and even zero-shot learning. Thanks to the inspiration research atmosphere in SMU, my colleagues and I are confident in making more exciting achievements in robust AI based on causal analysis. Thank you.